Number 5 says, determine the energy change associated with the transition from n equals 3 to n equals 2 in a hydrogen atom. So if you haven't already watched question 4, it's a good idea to look at that in terms of absorptions and emissions and high and low energy. But if you look here, 3 to 2, this is falling down. Here the atom is the system, so the answer is going to be negative. Why? Because the atom is losing energy. It had an electron at n equals 3. That's higher in energy than when that electron's in n equals 2. So the atom has lost energy. So this or this must be the answer. You can't have a positive value, so none of these could possibly be the answer. So if you just know that, you got a 50-50 chance. Well, now, in the previous question, we talked about how this, in a qualitative way, the relative amount of energy associated with these changes. Here we want the exact amount of energy. And to do that, we need to use something called the Rydberg equation, which is delta E is equal to negative 2.18 times 10 to the minus 18 joules times 1 over n final squared, okay, the final n in this case 2, minus 1 over n initial squared, the initial n in this case 3. Okay, note that if you subtract these the other way, you'll get the opposite sign. You'll get the same magnitude, but the opposite sign. Said another way, you'll get a positive value instead of a negative value. So if you do the math wrong, you need to think about what's actually going on. If something's falling from 3 to 2, the energy has to be negative, all right, which is why we did that at the beginning. So here, delta E equals minus 2.18 times 10 to the minus 18 joules times 1 over, the final is 2 squared, or 4. There should be a 1, not an n, minus 1 over 3 squared, which is 9. Okay, so delta E equals minus 2.18 times 10 to the minus 18 joules times 1 over 4 minus 1 over 9, 1/4 minus 1/9, which is negative 5/36. Okay, and when you do that math, you find sorry about that. This is positive 536 because 1/4 is bigger than 1/9. So it's positive 536. And when you do the math, you find that delta E is equal to minus 3.02 times 10 to the minus 19 joules, which is essentially the same as minus 3.03 times 10 to the minus 19 joules. Choice letter B. Question